Today we will be going over unique cases that can appear when plotting on a radar transfer plotting sheet. Unique cases are essentially when the relative motion triangle, or ERM triangle, collapses. So again, you start with your two triangles, your dividers with a sharp lead that is equal to the point, and a pencil. So there are three different types of unique cases that we can come across. First one we're going to talk about is same course, same speed. Essentially when your first and second bearing, your R and M, are right on top of each other. Your E is somewhere in a different direction, but essentially your ER and your EM are equal to each other, showing same course, same speed. The next is opposite course and same speed. So your first and second range and bearing can still be different, but your E is laying across on that RM line. And the third is when a target is dead in the water, or DIW. That means that there is no E to M relationship for them. Ergo, they are just floating dead in the water. Sometimes the dots do not align perfectly, such as these cases, and the triangle has collapsed. Best thing to do in these cases is to draw your motion lines. E to M is them, we are E to R, RM is relative motion, and then measure the direct values. So we will start with our own ship info. We have a course of 000 and a speed of 10 knots. We take our first range and bearing off of a target at 12 o'clock. We have a bearing of 180 degrees true and a range of 4.9. Now, before we even get to plotting this, let's try to figure out what scale we want to use. Again, you want the biggest ERM triangle. So today we're going to go ahead and use the 6 nautical mile scale that I've highlighted. With the 6 nautical mile range scale, each range ring equals 1 nautical mile. So let's start by squaring up our bearing from the center and down to that 180 degrees. And to figure out where we should draw this bearing line, we could just count out to where about 4.9 of that range will be. Now we take our dividers and measure out 4.9 nautical miles. Again, once you have chosen the range scale, you are stuck with that range scale for the entirety of your plot. I really like using dividers that have a wheel on them because I know that distance won't change when I lift it from the paper. So let's label it. We label that first range and bearing R with the time of 12 o'clock. Okay, now we take a second range and bearing 5 minutes later at 12:05. We have a same bearing as 180 degrees true and the same range as 4.9 nautical miles. So we don't really have to replot this because it's in the same exact spot. So we just label it M1205. Be sure to always label everything you ever put down on that sheet. Okay, and let's start creating our E so we can find our motion compared to theirs. So our ship's course is 000. Again, we draw our course in reciprocal away from R. So if we are going 000, we draw the line in the 180 direction. Now, luckily, we don't have to move around our triangle because it's already perfectly lined up. So let's draw that line. Next, we have to figure out the distance that E should be from R. And again, we do this by using 60D Street. D stands for distance, and then speed and time. So since we're looking for distance, we use our own ship speed of 10 knots, the time that we're using between bearings and ranges, which was 5, and then we just divide that by 60. So we get a distance of 0.83 repeating. Now you won't be able to measure that second decimal place very accurately, so we just ballpark on the scale of 0.83 repeating. Okay, we do that from R along that direction of 180, and that is our E. We label that again with the timestamp of 12:05. So now you can clearly see how our ERM triangle has completely collapsed, and our R and M are on top of each other. You can clearly see that E to R equals E to M. E to R is our motion, E to M is their true motion. So because they have no R to M relationship, there's nowhere to draw out a relative motion line towards us, or away from us, in a different direction. So they have no relative course or relative speed. You simply just put NA for not applicable. Now again, their E to R and their E to M are the same exact measurements. When ER equals E to M, that means that our true motion is equal to this target's true motion. So we simply just put what our true course and what our true speed are for their true motion. This vessel's true course is 0, 0, 0, and their true speed is 10 knots. Now let's talk about that CPA. They aren't getting closer, they aren't getting further. They are staying exactly the same. So their closest point of approach is 4.9 nautical miles. Their TCPA, again, they're not going closer to us or further. They're currently at that 4.9 nautical miles. So we could just put an infinity sign. We could technically put NA. We could put 12 o'clock when that first range and bearing was taken, or 12:05 when that second range and bearing was taken. So, situation. If you get asked this question on your assessment, you simply write same course and same speed. Now, if we draw their little vessel out from E to M, them, we see that this vessel is facing us. So we would see their red and green side lights along with a white mast headlight. I always recommend drawing in the light colors just to always help you remember and easily visualize it. And then when you get asked, is this give way or stand on? It is simply just NA. There is no risk of collision. There is no crossing head-on overtaking situation. So you put NA or no risk of collision. And that concludes our ERM unique cases, same course, same speed lesson for today. Thank you very much for watching. Let me know if you have anything to ever add to my YouTube videos, or if you ever want to see something else. Here's all the information on the screen if you want to try it yourself or follow along. Thanks.